perfectly well also, okay? And I'm not going to waste time to find IZZ. I don't think I need IZZ or I. So if this is our transformation, this is Y, this is our Z, okay? From what I've declared, the centroid is exactly down here. Okay, 1.5 meter, okay, from the top. So the datum is at the centroid, that's why I specify. So number 3, analysis starts from Y max, okay? So this is our analysis direction. So everything still apply, okay? If we go from the bottom, this is still our analysis direction. Number 4 is that number 4 is first moment of area. Cannot cross the centroid. Okay. Now rule number 5, I think I'm going to change the words a bit. Q cannot flow in the reverse direction. Okay, it cannot flow in the reverse direction. Later on, I'll elaborate what do we mean by it cannot flow in the reverse direction. Okay, and then for thin wall analysis, we have another law, number 6. Thickness, geometry, orientation is perpendicular to Q. Okay, right. So now the first thing we will do is we're going to design the shear flow, right? We're going to design the shear flow now, okay? So we know that Q comes from the top. The web control the flow direction. Then it goes out, and then it comes here, okay? So down here, you have 2 terminals. At the top, you have 1 terminal, okay? Right, you can see for yourself how is it. You can see, right? Oh yeah, it's so big, obviously you can see. Okay. Okay. Now I need to access another software because I need to cover things up. Okay. Go on. Hey Eugene, come on, wake up. I need to go to PowerPoint. Wait, my bad, wait, okay. PowerPoint. My bad, wait. I need to draw a color box. How to draw a box now? I don't need a text box. Okay. Okay, yeah, orange is good. Okay, we pick orange. Yeah, I'm going for a bit retro today, okay? Okay, I'm going to paste this. Okay, and I move this, good, okay? Now I'm going to get this diagram again, okay? And, okay. So we know that the first moment of area, right, cannot cross the centroid. So this is our centroid, right? Our analysis cannot centroid. Okay, why I'm doing this for? Question for you all. Is this a box beam or is this a white flange? Anyone? Yes. Well done. It is both. Okay, it is both. Why both? Okay, why both? Well done. Okay, why both? At the top, okay, so this one I call top, this one I call bottom. Okay, I do apologize those online. So the answer is both a box beam and a white flange. Okay, why is that? Okay, if you were to refer to your first diagram over here, right? In a box beam, the one on the left, okay, so anywhere above the centroid, I don't like it, they call it neutral axis. This is garbage, but this is a centroid, not a neutral axis, okay, right? In a box beam, you can see above the centroid, you have one terminal. Agree? If you go into a white flange now, right, above the centroid or below the centroid, you have how many terminals? 2. Jawohl. Yes? Okay, now you come back to here. Okay, that's why I love this question. Okay, this question, if I were to cover, okay, let me paste again, copy. Right? If I come on, seriously, if I were to cover, now if I were to cover the bottom, what do you see now? Right? You will see a box beam analysis. Okay, right? And then if I were to cover the top on the next diagram below, right? Now if I cover here, now what do you see? Okay, now you say, oh, Eugene, we now have a what? White flange. Okay. So the question is this: how will this help you determine your first moment of area? The first moment of area is the one that everyone is confused. Okay, even me, I sometimes get confused, but not anymore. Okay, so we know that this is our terminal. Okay? We know that this is our terminal. Right? The Q, oh, that's not, can you see the color? Or, yeah, I think I'm color blind. That's why my color definition is like really shitty. The Q, one will go the other side, one will go to the left, and one will go to what? To the right. Okay? So my piece of advice is you put a comma down here, you will have what? 2Q. One going towards the left, the other one going towards the right. So now the area of consideration is this area now. Okay, that is your first moment of area. Okay, so now Q about the z-axis is equal to a y bar. Okay, a y bar. So the width, I cover up the width. Let me see what's the width. The width is 2 minus 0.3, 0.3, 1.4. Okay, so the width is 2 minus 0.3 minus 0.3. Okay, why minus 0.3? Let me, I do apologize. Okay, let me copy and paste this. Then you can see better. Okay, so you can see why minus 0.3 now. Yes, right? You have 0.3 here. You have 0.3 here. Okay, so that's the width. The depth is 0.2. Right? And then the y bar is 1.5 minus by 0.2 divided by 2. Okay, so this will be equal to 2 minus 0.3 minus 0.3, 1.4 multiplied by 0.2. So 1.5 minus 0.2 divided by 2, 1.4. Okay, 1.5, yeah, it's 1.4. So your first moment of area is 1.4 plus 0.2, 1.4 times 0.2 times 1.4 is equal to 0.392. Okay, it's equal to 0.392 inch cube. Okay. Then the shear explain now what direction? Z direction. Right, it's moving along the Z axis. Right, so it's equal to Vy over IZZ. QZ is 0.392. The thickness is 0.2. Okay, the thickness is equal to 0.2. Now you have to put a 2 down here. Okay, this is for the thickness. Okay, that is for the thickness, and this is because of the 2Q that I put down here. That's why I highlight that you have to write down the word, you have to write down 2Q. So this will be equal to Vy over IZZ multiplied by 0.392 divided by 0.2 divided by 2 is equal to 0.98. What am I doing down here? It's equal to Vy minus IZZ 0.98. Okay, 0.98. Okay. Now that is for 2Q. Okay. Now, what are we trying to do down here? Okay, we are trying to find what is our maximum stresses at which point. Okay, so that is our top. We don't know what is Vy. I did not bother to calculate IZZ yet. Okay, why? Because Vy and IZZ are what? Are constants regardless whichever point you want to find. Yes or no? Remember the rule? Rule number 1. V and I are constant. Okay. Now let's look at the one below. Okay. The one below is we have it as a white flange. Okay. We have it. Now watch this. So we are going to construct the shear flow. Okay. We're going to construct the shear flow. So the shear flow go like that. I'm going to use a different color. So we know they end up in 2 different terminals. Right? So now we're going to write down, okay? So we are aware that this will be a white flange analysis. Okay? When it's a white flange analysis, just put the word Q. Just one Q. Because what happened on the right-hand side has nothing to do on the left-hand side. Because they end up in 2 separate what? Terminal. Yes or no? Right? So the first moment of area that we're going to take is only going to be from this section. Right? Because the analysis starts from the furthest distance and the terminal is down here. Okay, that is the first moment of area we're going to calculate. So we are going to quickly calculate its Q is equal to area, the width is equal to 0.7, the depth is 0.2, the y bar is equal to 1.5 minus by 0.2 divided by 2. Okay. So this is equal to 0.2 divided by 2, 1.5 minus the 0.196. Okay. And then finally, the shear x z at point A is equal to Vy over IZZ 0.196 the thickness is equal to 0.2. Okay, so 0.196 divided by 0.2 is 0.98. Vy over Izz is 0.98. So what we realize is this, okay? So the first one is at point B, the other one is at point A. Point A and point B share the same magnitude of what? Stresses. So where is the highest stress? We continue again on Wednesday, okay? Now listen, I know today you have a term test, okay? I'll tell Dr. Chin about it. If you have to miss your 2W, is it 2W? Yeah, miss it, find a place comfortable to write. Listen, more important to me is this. Don't be too stressed. If you don't do well, I will make you rewrite. What do I mean by rewrite? Okay, I'll give you your question back. You find your mistake. This is what real engineering is all about. When you do something wrong, what will happen? Your supervisor will give you back and you have to do the what? Correction. Okay, so don't be too stressed about it. Are we clear? Okay, it's not necessary to be so stressed. If that's the case, welcome to Jamaica. I'll see you guys when? When do I see you? Wednesday, okay?
Tyser, I had a question about the midterm.
Yes.